Okay, so the next problem is number 20 in your book, and the problem reads R of t is t to the fourth plus 6t squared minus 2, and we want to find out critical values, minimum and maximum points at the interval of 1 and 4. So again, I don't know what the function looks like, but I can still solve this by just working it mathematically. And again, I'm looking for the critical points. I'm looking for when the tangent line is 0. But to find that tangent line, I first need to find the derivative of this function, which is 4t cubed plus 12t. And that's it. So, so I want to find out where it's 0. So my function there. Oh, so at this point here, let's see. I want to anywhere I have. I want to zero it out, right? So I can actually factor out a 4t from this and get t squared plus 3. So 4t equals 0. T will equal 0. And then t squared plus 3, and we want to zero that out. That would be negative 3t squared, so that's going to be t in the square root of, or t squared equals negative 3. That's going to have to stay that way because I can't have a square root, a negative number as square root. So yeah, that's going to have to be it for that one. Okay, so as I continue on here, let's see here. So I want to find out on my function. I want to see where my function is, or what my function is going to look like at my interval points. So real quick, I figured out what my critical point is. My critical point will be at 0. Okay. And now I want to find out if that's the x, what's my y going to be? So I need to plug it into my original equation. So it's going to be 0 to the fourth plus 6 times 0 squared minus 2. So that's going to be minus 2. So my critical point is at 0, negative 2. All right. Now, here, let me draw my graph. So my graph here at negative 2, at 0, negative 2, that's going to be where my critical point lies. Now it's interesting because if you look, I'm going to highlight my intervals. It's at 1 to 4. So that's 1 to 4 over here. But you'll notice here that my critical point is at 0, negative 2. So that means my critical point is actually outside my interval of 1 and 4. Which is okay, I guess, because that's what it asked for. It asked for critical points and maximum and minimums from the interval 1 to 4. But in this case, my critical point is outside of that interval. So let's just keep moving forward either way. All right, so my original function, I want to find out where my points are from 1 to 4. So I want to find out at 1, r to the 1, from my original function. So that's going to be here. That's going to be 1 to the fourth plus 6 times 1 squared minus 2. So that's going to be 1 plus 6 minus 2. So that's 7. That's 5. So r to the 1 is 5. And now I want to find my other interval point is 4. So I go back to my original equation because that's where I'm going to find what it looks like on my graph. Plus 6 times 4 squared minus 2. So 4 times 4 to the fourth power, 256, plus 4 squared, that's 16 times 6, that's 96, minus 2, so that's 256, 256 plus 94, that's going to be 350, that's pretty high. So I found my value. So at 1, at this point right here, it's going to be 5. And then at 4, it's going to be 350. So it's way off the charts. So this is what my graph looks like at that interval. At that interval, I have a minimum of 5, and I have a maximum of 350. And then I have a critical point. So let me highlight all my important stuff here. My critical point is at negative 0, negative 2. My maximum is at 350, and my minimum is at 5. So let me show you on the graph what it's going to look like. So on my calculator, I'm going to plug in my original formula, right? So it's going to be t to the fourth plus 6t squared minus 2. And then I'm going to go to my window. I'm going to go to my window, and I'm going to hit the minimum of 1 and my maximum of 4, because that's what my interval states. And then I'm going to plug in negative 2, because now negative 2 is technically not my minimum in that interval. My minimum is actually, let me go down here, my minimum is actually 5. My minimum is 5. And then my maximum is 350, and that's because that's what I found in my formula. And then I graph it, and there's my graph there. That's kind of what it looks like. Okay, so in fact, let me change my window a little bit. Let me go back to what I had earlier in negative 2 as my y minimum, because that'll give me an even, yeah, it's still the same. So it has that kind of exponential look to it. So at 1 it's 5, and then at 4 it's 350, so it goes off the scale quite a bit. And so hopefully this video helped in solving these problems. Remember that the only reason in my as I look, I'm going to square this, as I look at my original equation, the only reason why I go and I need to find my derivative is because that derivative, when I find that derivative at 0, okay, when I zero out my derivative, that's what gives me the critical points, because that derivative gives me the point at where the tangent line, the slope, is 0, which means that's when the graph is making a turn. It's either it's going up and it's going to make a turn to go back down, or if it's going down, it's going to make a turn to go back up. It's either going to make a U shape or it's going to make a like an N shape. So that's why I find that derivative. So that's the only reason why I need that. And then after that, I have to go back to my original formula and plug in my interval points so I can see what the graph looks like and find my minimum and maximum points. Okay, we'll work some more of these out in class. So for now, good luck in your studying.